Hello guys, welcome to econometrics. We're looking at applying the Granger representation theorem step-by-step ECM in Eviews. The Granger representation theorem was popularized by Eviews and Granger, and the theorem states that if two variables y and x are co-integrated, then the relationship between the two variables can be expressed as ECM. And now this means that for us to apply the error correction mechanism to a model, all we have to do is to make sure our variables must be co-integrated, and for our variables to be co-integrated, these variables must be stationary at first difference. So after our linear regression model is specified that GDP is a function of government revenue and the raw term, the first thing we have to do is to determine the stationarity of GDP and government revenue using Eviews. So when I go to Eviews, we click on GDP. We determine stationarity. We go to unit root, standard unit root test. We click on level. We click OK. 0.9897, which is not significant. GDP is not significant. It's not stationary at level. So we'll now test for first difference. Okay, GDP is stationary at first difference because probability value of 0.0185 is less than 0.05. So we'll now go to government revenue. Okay, we'll now click on view, unit root test, standard unit root at levels that are the same part 0.9984. It is not stationary at levels. Let's check for first difference. Okay, probability value of 0.0022 shows that government revenue is stationary at first difference. Okay, that is that. Now that we've ascertained that the ADF shows that GDP is stationary at first difference, also GDP shows that the ADF shows that government revenue is stationary at first difference. So for detailed lecture on stationarity testing and reporting, see video posted on March 23, 2025. And now that we've ascertained the stationarity of our variables to be at first difference, the next step is to determine the long-run equilibrium relationship between GDP and government revenue. So we have to do this using Eviews. We go to our Eviews platform, and then we open variables as a group. Then we click view, and we go to co-integration test, and we click on single equation co-integration test. We adjust the test method is Granger. We adjust our last specification to fixed. Then we'll additional trend, we include linear trend. Then we click OK. Then you can see that the two variables, government revenue and GDP, are significant at 5% level of significance, which rejects the null hypothesis that the series are not co-integrated. So both variables are what? They are co-integrated. So we name them as group. And then we'll now move to the next step. What did we discover once we did the co-integration test? The Granger co-integration test shows that the long-run equilibrium relationship exists between GDP and government revenue. So for detailed lecture on Granger co-integration testing, see video posted on April 4, 2025. So the next step is for us to apply the error correction mechanism to the model. So our model changes from GDP is a function of government revenue to first difference of GDP is a function of first difference of government revenue, including the error correction term. So we're going to use Eviews to do that. The first thing we do is to generate the residuals after estimating OLS. So we estimate the OLS, static regression. Okay, estimate equation. And we have log. Okay, pardon. We have log GDP, then log revenue. Okay, so this is it. This is what we got. Okay, so now that we've gotten done the OLS, We'll now generate our residuals. This is the residuals. We generate the ECM from there. Click on generate. We type ECM, which is equals to residual receipt. Press OK. Good. Now we've generated our ECM. This is the ECM. So all we have to do now is to estimate our ECM. We have to include it as we so the difference include the difference term d log GDP. It's a function of d log government revenue. Then we include the error correction term. Okay, it is what we've got. Discover that revenue is not significant at 5%, and in this model, and look at the worsening level up to 2. So what we have to do now, we discover that there is not presence of time in this model, so we have to include time. We have to include the presence of time, and the inclusion of time is lacking in the model. In economics, the dependence of the dependent variable on independent variable is rarely instantaneous. So very often the dependent variable responds to independent variables with a lapse of time. So such lapse of time is called a lag. So in order to capture lags in the ECM, we have to determine the appropriate lag length to use, lag length criteria. So all we have to do is to go to Eviews. We need to determine the right amount of time to include in this model, or lags to include in this model. Let's save this model and leave it as ECM. ECM already exists. Okay, let's leave it as equation 1. Okay, equation 1. Okay, let's determine the lag length. We'll go to quick, go to estimate var. GDP is exogenous. We can log GDP, and then exogenous constant, and log revenue. Okay, click OK. Now this is a var equation. Let us click on view to go straight to lag structure, and then we click on lag length criteria. Okay, let me use 10 to give us varieties. 10. Okay, good. Now this is lag length criteria. Let's go to our PowerPoint and look at it. This is the lag length criteria, where we have the Cointegration criterion giving us 4 lags to use. The squats criteria, formation criteria is giving us 2. So while other ones giving us 4, and that of LR giving us 10. But we'll go for Akaike information criterion. It gives us 4. It's a better one. It gives us 4. So we'll now go back. Let's save this var equation. We've saved it. Okay. So we'll now go to the ECM to incorporate the 4-year lags. We start with d log GDP. Let's get 4 variants of it. 1, 2, 3, 4. Okay. Now let's include the time lags. 1 minus 1. Then we close the bracket. Okay, move here. Open bracket. Minus 2. Close the bracket. Give space. The next one, the minus 3. Then we close the bracket. Next, the 4th lag, put here minus 4. Close the bracket. Then for that of revenue, we also have to duplicate it into 4. 1, 2, 3, 4. Okay, we go back to include the first year. Minus 1 bracket. Go to the second past second year. 2, close the brackets. Then we'll come here. Minus 3, close the brackets. Squeeze. Then we'll come here. Minus 4, close the bracket. Okay, now we've gotten the 4 lags incorporated in the model. Let's check it out. Okay, good. This is the model. ECM model for the appropriate lag length. Now we'll discover something. We discover that 1, 1, 1, 2, 3, 4, 5, 6, 7, 8, 9 of the variables and the which comprise the lags are not significant at 5%. So this form of ECM is referred to as the over-parameterized ECM. Over-parameterized ECM. What is an over-parameterized ECM? Now, over-parameterized ECMs are an ECM that has more parameters than necessary in the model. It includes more lag variables, and it has more variables that are not significant in the models. Okay. Mostly over-parameterized ECMs are the ECMs that have lags from the lag length criteria. Like what we did here was using 4 lags, and we incorporated the 4 lags in both variables, and that is, we discovered that more than 6 of the variables are not significant in the model. So what we have to do next is to make sure we have a parsimonious ECM. A parsimonious ECM has fewer parameters. A parsimonious ECM avoids overfitting the model like the former ECM did. And also parsimonious ECM trims variables to only those that are significant in the model. So let us go and trim those variables that are not significant. First of all, we have to name this ECM. We'll name it over-parameterized. Okay, good. So now let us copy what we typed. Copied it. Okay, so we now take it to this side. Okay, let us estimate a new equation to make a parsimonious ECM. Now we've seen, let us take out GDP at lag 3 and 4. GDP at lag 3 and 4, let's take them out. Let's see what becomes of the model. Take them out. Okay, so we now have, that's what we have. Okay, this is what we have. Let's put it side by side to compare. Okay, now we have 1, 2, 3, 4, 6, 5 variables are not significant. Okay, let us remove revenue, the second and the third lags, and common revenue. Okay, good. Now we see now the ECM is significant, but we still have revenues that are not significant. We have to trim them out to make sure we get significant figures. Revenue, we take revenue out, press OK. Oh, we still have one that is not significant. Let us take GDP. Let's test out GDP lag 2. Let's see if one will be okay for us. Okay, we've taken out GDP 2. Okay, perfect. So GDP lag 1 at first lag is okay for us. So this is left with revenue not significant. Let us take out this revenue. Okay, good. Now we have a perfect model. Where we have at oversim is 2, exactly 2. And also we'll talk more about model diagnostics in subsequent lectures. But now the ECM now is not significant at 5% compared to the ECM or the over-parameterizer is not significant at 5%. Okay, but this is the ECM is significant at 5%. Okay, now this revenue, a 4-year lag revenue is significant, which is accepted, and 1-year lag of GDP. Now, what is the possible interpretation of this? Now that we've gotten a model and an ECM, what is the possible interpretation? Now, the ECM gives us the short-run adjustments, the direction of adjustment, and the speed of adjustment when it comes to their coefficients. Now, for the short-run adjustment, the ECM coefficient is minus 0.067293. This implies that for every 1% deviation from the long-run equilibrium relationship between GDP, its past value, and 4-year past value of government revenue, the GDP will adjust by approximately 0.06729% in the short run to restore equilibrium. That's for the short run adjustment. Now for the direction of adjustment, this is interpretation. The negative sign of the ECM coefficient of minus 0.067293 indicates that if GDP is above its long-run equilibrium value, given its own past values and past government revenue values, it will decrease in the short run to move back towards the equilibrium. That is for direction of adjustment. And then for the speed of adjustment, you can say the ECM coefficient is minus 0.067293. This implies that for every 1% deviation from the long-run equilibrium relationship between GDP, its past value, and 4-year past value of government revenue, the GDP will adjust by approximately 0.067293% in the short run to restore equilibrium. See, restore equilibrium. Okay. So, what about the independent variables? Now, the coefficient of last year's or last GDP is 0.355139. This implies that 35.51% of last year's GDP growth persists into the current year. In other words, the positive coefficient suggests that an increase in past GDP values is associated with an increase in current GDP, indicating some level of persistence in GDP growth. The relationship is significant at a 5% level of significance. Okay, so for that of the government revenue, we discovered that the coefficient of 4-year lag government revenue is minus 0.037699. This implies that a 1 unit increase in government revenue 4 years ago reduces current GDP by 0.0377 approximately. And also the negative sign shows that higher government revenue 4 years ago is associated with lower current GDP. That means higher government revenue 4 years ago have suppressed the growth of the Nigerian economy at present. The relationship is significant at the 5% level of significance. Now, what is the implication of this result? And this might be as a result of austerity or fiscal drag. That is, higher revenue such as tax hike 4 years ago may have suppressed private sector activity with delayed effect on GDP. So the economic implication is that fiscal policy has weak transmission to GDP. So what is the solution? The possible solution to this is emphasizing the importance of forward-looking fiscal planning and structural reforms to improve policy transmission to support GDP. So that's all for our ECM, but there's something we did not look at to make sure our model, a parsimonious ECM, is very okay. And we're going to look at that in subsequent videos. We'll take a look at crucial model diagnosis to ensure that the model in which the error correction was applied to is fit for policy application. So thank you for watching.